I plus 3xyj, distance particular in the xy plane from 0 0 to 1 4 along a curve y is equal to 4x square. Find work done. Here is the solution. F is 2x square yi plus 3xyj. So f dr, that is equal to 2x square y dx plus 3xy dy. Now C, our curve C is y is equal to 4x square. So dy is equal to 8x dx. F dr, that is equal to 2x square into y. Y is 4x square dx plus 3x, put the value of y, 4x square dy. So that will become 8x raised to 4 dx plus 12 x cube plus 12 x cube into 8x dx, right? Because y is equal to 4x square, so put the value of dy. Dy is 8x dx, so put the value of dy, that is 8x dx. So finally we get 104 x raised to 4 dx. Now particular moves from 0 0 to 1 4, that is integration from 0 to 1, right? 104 x raised to 4 dx, because our integration is with respect to x, so that's why we are taking our limit is of x, right? 0 to 1, 104 x raised to 4 dx. So that is integration of x raised to 4 is x raised to 5 divided by 5, and then put the value, first of all we have to put 1 instead of x, and then we have to put 0 instead of x. So finally we get the answer 104 divided by 5. Question 1, second part. For what values of constant k does the system x minus y is equal to 3, 2 minus 2y is equal to k have no solution? Exactly one solution or infinitely many solution? A is equal to 1 minus 1, 2 minus 2, and b is equal to 3k, right? This A is a matrix, standard matrix. For these two equations, you can see the first row is the coefficient of the x and y from the first equation, and the second row of this matrix is the coefficient of x and y from the second equation, right? So this is, I think, 2x minus 2y. This is not only 2, this is 2x minus 2y, that is equal to k. And this b is a constant, which is right side constant in both the equation, 3 and k. So to check that this two linear system of equation have solution, exact in which case we have this linear system of equation have no solution, in which case the exactly one solution, and in which case the infinitely many solution, that we have to find, right? So here is our augmented matrix A, gem B, where put the A, 1 minus 1, 2 minus 2, 1 minus 1, 2 minus 2, 3k. Now we have to convert this matrix into a row echelon form matrix, right? So first of all, just try to understand what is the meaning of row echelon form and reduced row echelon form. There are three conditions. First of all, try to understand the meaning of leading entry or pivot. The leading entry means the first non-zero element of the row, which are going from left hand side to right hand side. Whenever we are going from left hand side to right hand side, the first non-zero element, that is our leading entry, or sometimes we call pivot of that particular row. Now the first condition to become a row echelon form is, if there is any zero row, it should be the bottom of the matrix, right? So if there is any zero row, that means that row contains entirely zero element, right? So that type of row always should be in the bottom of the matrix. So that is the first condition. Second condition is, in that particular column in which we have leading entry, below that leading entry in that particular column, all the elements are 0, right? In that particular column in which we have leading entry, below that leading entry all the elements are 0. That is our second condition. And the third condition is, whenever we are going from left to right, right? Whenever we are going from above to below, our leading entry is going from left to right always, okay? So if these three conditions are satisfied, then we can say that our matrix is in row echelon form matrix. Now to become a reduced row echelon form matrix, there are two more conditions which we have to add in these three conditions. The first condition is leading entry must be 1. Our leading entry must be 1. That is the another condition. And the second condition is in row echelon form, as I told you that in row echelon form, in that particular column, except the leading entry, below that leading entry all the elements should be 0, but in reduced row echelon form, in that leading entry, above that leading entry, in that particular column all the elements should be 0. So that means what, in which column we have leading entry, right, except that leading entry all the elements must be 0, except that leading entry all the elements must be 0. So if these two conditions, so total five conditions satisfied, then we can say that our matrix is in reduced row echelon form matrix. Okay, and from these 5 conditions, the first 3 conditions are satisfied, then we can say that our matrix is in row echelon form matrix, right. So to solve any linear system of equation, the row echelon form matrix is enough, right. So we are converting this augmented matrix into row echelon form matrix, and then we solve this example. So let's see how we solve this example. See, this is 1 minus 1, 2 minus 2, right, 3k. Now we are multiplying first row with minus 2 and add into the second row. So that's why R2 minus 2 R1, right. Okay, we are multiplying first row with minus 2 and add into the second row. So that's why here written R2 minus 2 into R1. So first row is as it is, 1 minus 1 3. The second row is now 0. This is also 0, right, and this is k minus 3. Okay, now if k minus 3 is equal to 0, if k minus 3 is equal to 0, then the system has infinitely many solutions, right, because of in that case the last row becomes 0. So we have only one equations, that is x minus y is equal to 3. So in that case the y is now our free variable. We can take y is equal to k, right, and that corresponding to value of k we get value of x. So definitely we get infinitely many solutions. Now in k not equal to 3, the system does not have solution, because in that case what happened, k not equal to 3 means this part is non-zero, right, and this is 0 0. That means what, we get 0 into x plus 0 into y, that is equal to non-zero element. That is not possible for any x and y. So that's why this k not equal to 3, then system does not have any solution, and there is no unique solution, because of the rank of A is 1 and the rank of augmented matrix is 2. So that's why these two are not same. So that's why there is no unique solution. So in this first question, all the question was asked in 2 marks. Okay, there are 7 questions in the first question. So the question 1 is total 14 marks, have 14 marks, and all the question have 2 marks, right. Okay, so this question 1 and second part is complete. The third question, solve following equations by Cramer's rule. There are 3 linear system of equations, x1 plus x2 plus x3 that is equal to 9, then 2x1 plus 5x2 plus 7x3 that is equal to 52, then 2x1 plus x2 minus x3 is equal to 0. So here we have to find 4 determinants. First is capital D. This is exactly the coefficient of x1, x2, x3 in all the 3 equations. You can see the first row is the coefficient of x1, x2, x3 from the first equation 1 1 1. Then this is second row is exactly the coming from the second equation, the coefficient of x1, x2, x3, and third row is coming from the third equation, the coefficient of x1, x2, x3, right. So 1 1 1, 2 5 7, 2 1 minus 1. So just try to find out this determinant 1. this is minus 5 minus 7, right? So minus 12, right? Minus 12, then minus 1 into minus 2 minus 14, right? So minus 16 into minus 1, so plus 16, minus 12 plus 16, so that is 4, and then plus 1 into 2 minus 10, so that is minus 8. So 4 minus 8, that is minus 4. Clear? Similarly, you can find D1, 9 1 1 52 5 7 0 1 minus 1. Because of, see how we make this determinant D1. The second and third column are as it is. Instead of first column, we have to add this coefficient, which is all the right hand side part of the three of the equations. You can see 9 52 0. So this is 9 52 0. The first, instead of the first column from the D, we have to add 9 52 0. The second and third column are as it is, 1 5 1 1 7 minus 1. Now this is equal to minus 4, correct? Now this is also minus 4. Now you can easily find out the value of this determinant. Okay, so that is left on you, right? So just try to find out this determinant, that is also minus 4. Then D2 is, instead in D2 you can see the first and third column are as it is from the D. Instead of the second column, we have to add 9 52 and 0. Okay, so this is equal to minus 12. D2, the value of D2 is minus 12. And then D3, the value of D3, that is equal to 1. The first and second column are as it is, 1 2 2 1 5 1. You can see 1 2 2 1 5 1, and then instead of third column we have 9 52 0, right? 9 52 0. So that is equal to minus 20. Okay, now the value of x1, that is equal to minus 4 divided by minus 4 equal to 1. The value of x1 is minus 4 divided by minus 4 equal to 1. Because of this is D1 divided by D. The value of x2, that is D2 divided by D, that is minus 12 divided by minus 4, so we get 3. And the value of x3, that is minus 20 divided by minus 4, that is equal to 5. So if you want to verify that our solution is correct or not, put the value of x1 x2 x3 in three of the equations. Let's try to check. 1, you can see 1 plus 3 plus 5, so we get 9. Then 2 into 1 2 plus 5 into 3 15, 15 plus 2 17 plus 7 into 5 35. So 35 plus 17, we get 52. And then 2 into 1 2 plus 3 5 minus 5, that is equal to 0. So our solution is correct, right? The value of x1 x2 x3 is correct. We are using here Cramer's rule to find the value of x1 x2 x3. This question was asked in 2 marks. All of the 7 question was asked in 2 marks in this question paper, right? The first question is have 14 marks. Question 4, here is a transformation T, which are going from R2 to R2, domain and codomain both are R2. T of xy is equal to 2x plus y, x minus 2y, right? If T 1 1, if so, find T inverse. So we have to check that T is 1 1. Our transformation T is from Euclidean linear transformation, and in Euclidean linear transformation our benefit is that we can find the standard matrix, right? So T of xy is equal to 2x plus y, x minus 2y. So our standard matrix T is 2 1 1 minus 2, and determinant of T, that is equal to 2 into minus 2, that is minus 4, minus 1 into 1, that is minus 1, so minus 5. which is not equal to 0, so that's why t is invertible and that's why t is 1 1, right? So in Euclidean linear transformation there is one important theorem that t is 1 1 if and only if t is invertible, right? T is invertible, and in Euclidean linear transformation we have a standard matrix, right? So we can easily find the determinant in 2 cross 2 or 3 cross 3 matrix. We can easily find the determinant. If determinant is non-zero, we can say that t is invertible, and that's why t is 1 1. Okay, in other words, that t is invertible, to check that kernel of t is equal to singleton theta. Okay, t is 1 1 if and only if kernel of t that is equal to singleton theta. So kernel of t means what? Those elements from the domain we have to find such that the image of that element that is equal to theta. Theta means 0 element, 0 vector from the codomain. Okay, so if this theorem, try to understand very carefully that here we use simply, we have 2 cross 2 matrix, so we can easily find the determinant, and determinant is non-zero, so that's why t is invertible and that's why t is 1 1. Okay, so now also here we have to find t inverse. So let's see how to find t inverse. Now here is another important theorem, that the inverse of the standard matrix T, that is exactly the standard matrix for the T inverse. The meaning of this statement: inverse of the standard matrix T, that is exactly the standard matrix for the T inverse, and in 2 cross 2 matrix we can easily find the standard matrix inverse of that matrix. This is our matrix. If you want to find the inverse of this matrix, that is exactly adjoint of this matrix divided by determinant of this matrix, right? What is adjoint of this matrix? Just we have to interchange these two elements. So minus 2 become here and 2 become here, right? And then change the sign of this another diagonal elements. So this to become minus 1, right? So minus 2, minus 1, minus 1, 2, correct? And divided by its determinant. What is our determinant? Minus 5. So minus 2 by 5, 1 by 5, 1 by minus 5, minus 2 by minus 5. So that is equal to 2 by 5 minus 1 by 5 minus